friends, in this video I'm going to show a very simple trick to write your own example for symmetric and skew symmetric matrices. So let's see first symmetric matrices. Here what we have to do is, whatever you wish, just write any elements at the diagonal entries. Let us write 3, 1, 5. You can write any other number also at the diagonal entries, at the leading diagonal. And what you have to keep in mind, that whatever entry you put here, just same entry you have to put downward also, or at the corresponding position as well. Like if I put 2 here, here also 2 has to be there. If I'm writing 0 here, here also 0 should be written. And if we are writing -1 here, so here also -1. That means these two entries has to be same. This should be same, this should be same, and this should be same. So let's try another example, and then I will also show that how it is symmetric, because these matrices will satisfy symmetric condition. So this is one example which we have created by our own self. Now let's write one more example. So as I said, write any number at the diagonal entries. So let us write 1, 0, 4. Okay. Now whatever element you will write here, same has to be present here. Okay. So let's write 3. So here also 3. Now if I am writing -5 here, so here also I will write -5. And if I am writing 2 here, here also I will write 2. Okay. Now let's check if these two examples which we have just created are symmetric or not. So for symmetric matrices, the condition is A should be equal to A transpose. That means even if I transpose this matrix, the matrix should be same. Similarly, if I transpose this matrix, the matrix obtained should be same as it is. So here in transpose of a matrix, in my previous video I have already explained what we do. We write row element in column form, column wise. So here the same thing I am trying to write. So I'll write 3, 2, 0 in column wise, 3, 2, 0. Then again 2, 1, -1 which is in row will be written in column wise, 2, 1, -1. Now the 0, -1, 5, 0, -1, 5. Now just check if this matrix is just similar to the new matrix or not. 3, 2, 0, 2, 1, -1, 0, -1, 5. Yes, that means it holds this condition. Therefore, the matrix we have written is symmetric matrices. And I told you the technique very nicely, that how easy it is. Similarly, here also if you see, if you write the row elements in column form, what we get. So here also when we check and we write row element in column form, so what we get? 1, 3, -5, 1, 3, -5, 3, 0, 2, -5, 2, 4. Now just check, both the matrices are as it is. That means A is equal to A transpose is satisfied. 1, 3, -1, 3, 0, 2, -5, 2, 4. So this is how we write symmetric matrices, and we also checked that yes, they are coming, their transpose is also same as the given matrix. Now let's see how we can write skew symmetric matrix. What is the trick? So here the trick is the diagonal entries must be 0. The diagonal entries must be 0, and whatever is the remaining element that we write has to be in opposite sign. Like if I write 2 here, here it should be -2. Now if I write 1 here, here it should be -1. And if I write 3 here, here it should be opposite in sign, -3. And condition for any matrix to be skew symmetric is A should be equal to -A transpose. This is the condition. Now for this matrix, if we check, are we getting minus of A transpose? So let us say this is A. So when we transpose it, what we get? When we transpose it, we write row in column form. So 0, 2, -1, then -2, 0, -3, 1, 3, 0. And then what we have to do when we check the two elements, yes, it is not same. So what we have to do, we have to multiply this matrix by a negative sign, that is -A transpose we have to do. By doing so, what we get? By doing so, all the elements are getting multiplied with negative sign, that is 0, 2, minus 1, minus 2, 0, minus 3 and 1, 3, 0. And now when you check this A and minus A transpose, are they not equal? Yes, they are equal. So skew symmetric condition, skew symmetric matrix condition is that A has to be equal to minus of A transpose, which is true here. So this is how we can write our own example which are infinite in number for skew symmetric matrix or for symmetric matrix. So this is how we create our own example. Similarly, you can create one more example. Like I said, suppose we are writing a skew symmetric example, skew symmetric matrix example. Diagonal entries has to be 0, and then whatever entry you put here, negative of it should be here. Whatever you write here, negative of it should be here, and whatever you write here should be the reverse in sign with respect to this element. For example, if I write 3, here it should be minus 3. If it is 2, here it should be minus 2, and if it is minus 1, this should be 1. These values should be in opposite sign but same in value. The integral value has to be same with opposite sign. So this is what is the relation we have to keep in mind, and then the required matrix is obtained. Thank you.